just some of the things that we as an ecosystem really need to do to try to get there in a way that really preserves some of the important properties that Ethereum has today. And ideally even have even better properties. So ERC-4337 is the lifeblood of the account abstraction ecosystem as it exists today. And ERC-4337 is the result of basically 7 years of work on the account abstraction problem, and also 7 years of evolution of what the account abstraction problem, or kind of the problems that are trying to be solved, even are, right? And for people who have been following Ethereum ever since it launched, you might have heard of EIP86. Who here has heard of EIP86? Okay, perfect. Then there's EIP208. Then there's EIP2938. Who's heard of EIP2938? Okay, good. See, that's there's a lot of this kind of deep lore, right? And every time these EIPs happen, it does a better and better job of solving specific technical problems with account abstraction, and often the scope ends up increasing a bit, right? So one of the things that I personally notice with account abstraction is, for me, the problem, it always was about security, right? I've been a multi-sig wallet shill pretty much ever since I wrote that article in Bitcoin Magazine about multi-sig wallets back in 2013, right? And even back a bit before then, I wrote an article for Bitcoin Magazine just complaining about how easy it is for people to get their funds stolen, right? There's a lot of these scare stories where a person had 25,000 BTC, they downloaded the wrong executable file, or they downloaded the wrong, .png file, which is actually a .png.exe file, but the operating system thought that it would be more user-friendly to lop off the .exe, and they double-click it, and stuff starts running, and poof, 25,000 BTC is gone, right? And things like this literally happens, right? And just more generally, I think the DeFi world sometimes takes too seriously the problem of getting people 6% APR instead of 4% APR, and not seriously enough the problem of really minimizing the chance that they get a negative 100% APR, right? And that basically improving security has and giving people easier ways to use multi-sig wallets, and also giving us a path to quantum resistance, and giving us a path to use other kinds of signature algorithms that just have better properties like Schnorr and BLS is just my inspiration, right? But then I look at why some other people get excited by account abstraction, and they're like, oh, I want to be able to pay transaction fees in USDC, or oh, I want to build an application that pays transaction fees on behalf of their users, right? And one response for me is to kind of get frustrated by people not not caring about security, but the other response is well, great. Actually, if we expand these protocols just a little bit, we can create something that really satisfies a lot of these goals and makes a lot of people happy, even if they're coming at the problem from totally different angles, right? So modern account abstraction basically solves this big collection of goals that a lot of different people have, right? So the way that I categorize these goals is I think about them as being security goals and convenience goals, right? And they're all useful and important goals. So on the security side, multi-sig wallets, right? Having wallets that you need multiple keys to sign off on an operation. Social recovery wallets, wallets where you can do things with one key, but if you lose access to the account, you can have some combination of multiple other keys that recovers the account, right? Or just the ability to do key changes and revoke access, right? This is the core thing that MPC just cannot do, that smart contract wallets can do, right? MPC, you cannot revoke access because all you're doing is you're just resharing the same key, right? And so if you trust a group of people once, you're trusting them forever, right? And revocation is just inherently one of those things that just has to be done on chain. You have to have some kind of on-chain state. Custom signature algorithms. So we in Ethereum often worry a lot about quantum resistance and making sure that we have a good story of if quantum computers come, what can we upgrade to? And quantum resistance, there are signature schemes that we can pretty easily upgrade to, right? In the sense there is Winternit signatures, there is snark-based signatures, there's all kinds of fancy signature schemes that you can use, right? Which is good. But With account abstraction, we can basically leave it to other people to actually make those algorithms, and we can make something that's fully generic, where all of the work of being ready for quantum is basically almost done now, but where users would be free to go and upgrade to this on their own time, right? Also, well, there's two ways to look at it, right? One way to look at it is we make it possible for people to have quantum secure addresses. The other way to look at it is we make it possible for people to create addresses that have quantum secure backups, right? So this is actually something that the beacon chain did for keys, right? Basically, the key is generated in such a way that like the private key itself is like the hash of a thing. And so if quantum computers come, then like there is a thing that you can prove access to that is even before the key that does not get revealed if you just can extract the private key, right? So like enabling this kind of preemptive upgradability to quantum resistance and making it sort of more universal is another thing that you can do. Actually, I mean, to be fair, people do underrate how like quantum resistance recoverable even the current system is, right? Like who here uses a wallet with a seed phrase? Well, so fun fact. If you have a quantum computer, you probably know that if an account has signed even one transaction, then you can, from a public key, from that one transaction, you can recover the public key. From the public key, you can use Shor's algorithm to recover the private key. But what you can't recover is the seed phrase itself, right? And so if we want to do an emergency quantum recovery, then like we can basically make the seed phrase itself be the new key, and like we can use a Stark of the seed phrase as your new key if a quantum transition happens, and like that way, basically like more than 90% of people could be safe already if a hard fork is done in the right way if a quantum computer comes, right? But account abstraction just basically gives us so much more flexibility to like implement all of these different things. So the SecP256R1 curve is the curve that is used inside a lot of trusted hardware modules that people have today. And so if we want accounts that are directly controlled by keys that are in existing hardware modules that are inside of people's phones, then supporting signature verification with SecP256R1 is just a great way to do that, right? So those are the security goals, convenience goals, paying fees with ERC20s. You are a person in Argentina, and the local Argentinian currency is hyperinflating. But what you want to you want to sell your bike, and you want to collect money that is not going to have half of it disappear on you in a year. You sell a bike for 70 USDC. You collect 70 USDC. Oh, you have a wallet. Your wallet has 70 USDC. But then you decide to pay for a coffee. Problem. Paying for a coffee requires paying transaction fees. Transaction fees are denominated in ETH. If you just have 70 USDC and 0 ETH, you're kind of screwed. So making it possible for people to like basically go through a builder intermediary where they pay the USDC to the builder does a one-time trade, and they're the ones that actually convert and use ETH to pay for gas and claim your USDC. Like this is this thing that paymasters can do, and it's also something that has become part of the account abstraction umbrella. Letting applications sponsor transactions on behalf of users if those applications have some other way of solving the anti-Sybil problem and verifying that they're not going to get drained. So also another thing that's valuable. And then finally, doing multiple ops at the same time, right? So who here has traded on Uniswap before? Who here has had the experience of having to first send one transaction to approve the token, and then waiting for that, and then having to send me another transaction to do the actual trade? Who here has had the experience of doing that before 2020, when EIP 15559 did not exist, and you often had to wait 5 minutes for the first transaction to confirm? So, these things are not nice. Who here would like to have the experience of being able to make an approve call and then be able to do the trade all within one single transaction? So this is something that account abstraction also enables, right? This is a convenience feature, but it's also a security feature, right? It's a security feature because if you want to do multiple operations, there's a lot of use cases where like there's an insecure intermediate stage, right? So like even approvals themselves, they're kind of insecure, right? Because you're basically saying, okay, I'm going to give approvals, and then users get tired of approvals, and so they just give like a lazy approve everything. And once you give the lazy approve everything, then like a malicious app only needs to, like ask one more signature, and then they can just like grab all of your tokens, right? And as we've seen, these kinds of apps do exist and they are a problem, right? So like if we can get rid of these sort of standing approvals as a concept, and if we can just have multi-ops where you just immediately approve exactly the right amount and then immediately grab and trade, then like that also solves a security problem for people, right? So account abstraction has lots of goals, which I think is amazing, and this is like a really beautiful and kind of uniting thing for the ecosystem, right? Because it means that lots of people who care about lots of different problems, like they have something that all of these people for different perspectives can unite behind. Now, challenge of account abstraction. Account abstraction is an ecosystem-wide effort. To really properly implement account abstraction and make it work for users, there's like a whole bunch of different participants that kind of need to worry about it and change things and make sure that they're kind of handling the transition well, right? So I group these into two categories, existing and new. And I think the reason why I care about making this grouping is because if you're new, then like you're in the process of building out today. And so the thing that you need to do is just make sure that you're building out in a way that works together with the way that account abstraction is building out. If you're existing, then like you need to rewrite stuff, right? So it's a somewhat different kind of work. So existing things, wallets, right? So wallets today, obviously, traditional wallets only support EOAs, but increasingly there's also a lot of new wallets that are being created around ERC-4337, and I expect existing wallets are also going to want to support ERC-4337 just because of some of the benefits that it offers. dApps. Lots of dApps rely on off-chain signed messages. If your dApp relies on off-chain signed messages, then if you want your dApp to also work with smart contract wallets, you have to support ERC-1271. If you want it to work with smart contract wallets that have not yet been published on chain, there is another ERC that supports that. I mean, I actually forget the number of that one, right? But there is an ERC that extends 1271 to counterfactual wallets, like wallets that have not yet been published on chain. This is like a big problem, right? Like even today, there's lots of application, like dApps that like literally break when you access them with something other than MetaMask. Like they literally break on Brave or they break on the status wallet, right? And like this is just an area where people need to improve, right? Like this is an area where there's like a lot of value in really fostering a much more diverse ecosystem and like really being standards compliant and making it possible for new wallets to emerge. Then developer tools. So developer tools today, including block explorers, including Web3.js, including a whole bunch of things, need to adapt around account abstraction. One specific example of this. Let's take the example I gave. You're trading on Uniswap, and step one, approve. Step two, trade. Now, sure, account abstraction makes it really easy for you to make that into one operation. But there's a problem. The underlying JavaScript libraries have no way to like give the wallet an instruction that says make a multi-operation. Like that is just not something that's possible. And so even if ERC-4337 exists, even if all that's possible, that's like in practice, users might still be forced to continue to send two operations. There are wallets that I've talked to that are solving that problem by basically making their own custom interfaces, right? They make their own custom trading interface, and that custom trading interface actually does the first call and then does the second call, which I think is totally fine, right? But eventually, like, we don't just want to concentrate users around a small number of applications. We want to make this generic so all applications can benefit. And this is something that like basically requires tooling on the on the Web3 JavaScript library level to really be able to accomplish. Also, block explorers need to support account abstracted operations. There's just like a long list of stuff that needs to adapt. Now, new participants, so layer twos. One of the big themes I talked about in my post on the 3 transitions is basically that there's an extra challenge in doing some of the really challenging things that we want to do with account abstraction at the same time as supporting many layer twos. If you want to do recovery, but you have accounts on a bunch of different layer twos, including accounts where you theoretically have the account, but you've never actually signed up and you've never even heard of the layer two, then like how do you actually do that in a way that makes recovery work well? Then privacy infrastructure, right? Like how do we do account abstraction at the same time as preserving privacy? How do we even do multiple layer 2s at the same time as preserving privacy? MEV infrastructure. So this includes like stuff like bundlers and existing PBS stuff, but it also includes, for example, protocol changes. So one example of this is there is increasingly a movement toward adding what are called inclusion lists, a protocol feature to Ethereum by which proposers can basically force builders to include specific transactions in either the current block or the next block. Inclusion lists basically remove the power of builders to censor even if they want to. Now, the problem is that if we just keep ERC 4337 as an ERC and we never enshrine anything, then ERC 4337 operations do not properly benefit from this censorship resistance. But if we actually enshrine ERC 4337, make it a protocol feature, and we make the inclusion list EIP cover it, then we solve the problem, right? And this is one of the reasons why I think there actually is value in enshrining ERC 4337 in the long term. Authentication methods, right? So this is like infrastructure that just gives people options for authenticating themselves. One of the kind of nice things that we have, I think, in Ethereum is this idea of the Ethereum address as a standard. Like any authentication method that you have, you can use create2 and you can make an ERC 4337 wallet around it and you can turn it into an Ethereum address, right? If you want to verify a particular SecP256 R1 key, give me the key, I have a deterministic function, I can turn it into an Ethereum address. If you want to verify a Japanese government's digital ID card, you can extract the public key from that card, and then you can do the RSA verification, create a contract, and then calculate the create2 address, and you can convert that into an Ethereum address. If you want to turn an email address into an Ethereum address, then you can use ZK email. You can create a ZK snark verifier that verifies snarks of proofs of access to the email. And if you do that, then you've converted your email address into an Ethereum address, right? So you can convert everything into an Ethereum address, and then if you use Ethereum addresses as the participants for multisig and social recovery, then you can kind of be compatible with all of these different methods, right? And then and just the existence of authentication methods itself becomes this like really important kind of infrastructure. And they can be used in multiple ways, right? So like if you think about ZK email, for example, for new users, maybe what you actually want is you want to just like minimize their need to learn new things. And what you basically, you just convert the email address into an Ethereum address and you just like directly put assets into that, right? But eventually the user is gonna want to upgrade. And they might want to be able to upgrade into a multisig, and in that multisig, one of the participants would be a backup using their email address, but then their other participants might be something else, right? So giving people like authentication options in a flexible way that makes them usable both as a one-of-one and as a participant in an MFN is like valuable, right? But like this is something where we just, I think, need to see as wide an array of different options available to kind of maximize people's choices. Specific examples of some cross-dependencies, right? I think one of the really important themes is that there's many different parts of the ecosystem that really benefit from working together here. Key changes and L2s, right? This is basically this problem that you have an account, and you're going to have an account on a huge number of layer 2s. And this is just functionality that people expect, right? Like you just expect that if you have a wallet, you can just switch to any network and you have an address on that network. Might not necessarily be the same address, right? That might be something that we have to move away from. But having an address on any network that you switch to. How do you combine that with the possibility of key changes, right? You want to be able to change your key. What happens when you change your key? And so the problem is that like what you don't want to do is you don't want to require changing your key to do 1,000 on-chain operations, including operations on layer 2s that you don't even know exist, right? And so what you want to do is you basically inevitably have to have some kind of workflow where all of your addresses on all of the different layer 2s somehow, maybe directly, maybe through a ZK, maybe through Merkle proofs, maybe through direct reading something, are able to read a key store contract, which could be on a layer 1, could be on a specific layer 2, and like directly get authentication from there. Either for every transaction in the long term, or in the short term, at least just for recovery, right? But for this to work, like this is a standard that basically requires layer 2s to do some work, and it requires wallets to do some work, right? Specifically, it requires layer 2s to, if you want to be efficient, to implement an opcode that allows them to read the Ethereum layer 1 state root, pretty much immediately, right? And this is, this is actually being thought of as part of a kind of layer 2 EVM initiative, and this is something that a lot of layer 2s are actually surprisingly close to being able to have even today. But this is just like a specific piece of infrastructure where if layer 2s go and implement this, then account abstraction becomes significantly easier. Cross-dependency, ENS and layer 2s. This one is a bit of a success story, right? If layer 2s prosper, then eventually you're gonna need to have people live entirely on layer 2s. And like, if Ethereum transaction fees get back to like even 2021 levels, ENS updates are gonna cost $100. We do not want ENS updates to cost $100. That is unacceptably bad UX. Therefore, users need to like actually live on layer 2s. There is an EIP called CCIP. I think it's ERC 3640, but CCIP is kind of the more like common name, by which you can basically have an Ethereum layer 1 own a specific domain, and then it essentially gives an object that includes some degree of off-chain calling the right to control, prove subdomains of that particular domain. This object could be anything. It could be a layer 2. It could also just be a server that signs messages, right? And so basically the way that this works is if you have a domain on a layer 2, call it bob.myl2.eth, and a user asks for bob.myl2.eth, then the CCIP contract, which actually owns the parent domain, myl2.eth, is going to return an off-chain data struct. It contains a list of URLs, and it contains a list of stuff to call. The user then goes and calls to a proof providing node, and you can have many of these. It's a one-of-n trust model. You can have a huge number of them. Eventually, a decentralized. Eventually, just like this should be part of something like the Portal network. And then you get a response with a Merkle proof, and then you have a callback function, and the callback happens fully off-chain, right? So this does not cost any gas. Reading is a fully off-chain operation, and the callback function then verifies a proof, and it tells you like what does bob.myl2.eth actually contain. So the nice thing about this is like most of this is already done. The piece that has not really been properly done yet is like basically just actually implementing the Merkle proofs. Like there already are CCIP implementations that rely on trusted intermediaries that provide signatures where the CCIP contract verifies the signatures. We just need to like add Merkle proofs, right? So like this is pretty close to done, and I kind of consider this a success story because it really shows how ENS has like basically actually managed to upgrade itself into something that really is layer 2 friendly. So those are just like some examples of cross dependencies, and I think the need for communication between different kinds of actors in the ecosystem if we really want the abstraction and layer 2 transition to work well. Needs for standardization, right? This is just a few examples of things that I think would also be valuable to standardize. Guardian selection, right? So, multisigs are a really powerful tool. Social recovery is a really powerful tool, and it gets used in different ways, right? So, like for example, when I talk to wallet makers that are trying to solve the problem of making an easy-to-use and friendly wallet that is still secure and that is still not dependent on a single centralized actor, one of the workflows that they often end up converging on is basically 2 of 2 and recovery, right? So you have a fast path, where the fast path, because it's a 2 of 2, which could be a 2 of 2 between the user, like a trusted hardware chip on the user's device and a server. It could be a 2 of 2 between 2 devices that a user has. It could be a 2 of 2 between the user's phone and an NFC. Like basically, it's a 2 of 2 that is where the chance that both pieces of the 2 of 2 get hacked is pretty low, but it's still very convenient. But on the flip side, the chance that you lose one of the 2 pieces is higher. And like that's the normal way that a user sends transactions. But then if a user loses one of the two pieces of the 2 of 2, then the user can go use the recovery mechanism, which is slower. It might involve multisig, it might involve a 7-day delay, it might involve a 7-day delay and a multisig. I mean, you could even do something clever. I think Martin actually suggested this to me. Something like a graded multisig where like 1 of 7 can sign a message with a 5-year delay, 2 of 7 can sign a message with a 2-year delay, and then you go all the way down and like 5 of 7 can do something instantly, right? Like you could do a lot of clever stuff here, right? And then that slow path allows you to kind of override the 2 of 2 and reset it to something else. Now, so multisigs are a really powerful primitive, and there's different kinds of like participants that make sense to have, right? So I think of multisig participants as being generally in 3 categories: institutional guardians, friends and family, and your own other devices. So institutional guardians, so there's 2 ways to do this, right? One way to do this is you have specialized institutional guardians who know that they are institutional guardians, right? So, basically Coinbase could offer a service that just says, hey, I'm going to be a guardian, and if you want me to sign a message, then like you could set what the instruction is, and you could require yourself in the future to just have to have a video call and provide maximum KYC if you want me to like actually sign a message here, right? And like that might actually be a good option for people that really care about their security. Another way of doing this is you could kind of co-opt existing centralized providers and turn them into guardians. The ZK proof of an email is one good example. You could also do a ZK proof of a government digital ID. You could do ZK proofs of like kind of wrappers of surprisingly many things, right? And if you do that, then like you take actors that are already providing security infrastructure outside of the existing blockchain space, and you just kind of turn them into Ethereum addresses, right? Anything that you can like cryptographically verify, you can turn into an Ethereum address with an on-chain verifier, possibly a snark, and create 2. So that's 2 kinds of institutional guardians: friends and family, right? If you have other people that you trust, then like also a great choice for guardians. But you want this to be people who ideally are like close to you but not close to each other. And I think often want to protect privacy, right? Like even if you trust people not to betray you, you don't necessarily want them to see all of your activity. And like this is actually a technical problem that we can solve. And then your own other devices, right? Like an NFC card, you can have a card on a chip these days. Sometimes like even government digital IDs basically are these kinds of devices, and you can kind of basically turn them into hardware wallets. Intentional hardware wallets, right? Hardware wallets are surprisingly tiny these days, and you can use them too. Like there are YubiKeys potentially. There's like lots of devices that are specifically for authentication that you could use, right? So there's like lots of these different guardians, and I think there is a value in encouraging the existence of an ecosystem with a wide variety of guardians, which can be used either as a one-of-one, like a signer, or as a one-of-one recovery, or as a participant in an M event. And it's like free for the user to decide in what form factor they want to use these, right? So like basically trying to encourage sort of commoditization of guardians as a service where they all follow the same kind of pattern. They don't try to dominate your user experience by like all creating their own UIs. They just like be the thing that they're supposed to be, is something that I think is like valuable in making the account abstraction and safety ecosystem grow better. Addresses on different layer 2s, right? So it feels like we're moving in the direction of, instead of everyone having the same address on every L2, people having different addresses on different L2s. And there's like lots of reasons why this kind of actually turns out to be a good idea, right? But though to be fair, it's still a debate, right? And I think there is the possibility that the debate swings back in the other direction, and we really go on like maximizing for having the same address everywhere. The reason why I think it's harder is, especially once you get into like non-EVM layer 2s, and you're not going to be able to like have the exact same address hash, right? But like that's then it becomes harder, right? So if you have different addresses on different layer 2s, there's basically 2 techniques that you could use to kind of work around that, right? You could have ENS, and you can have an ENS record that specifies your L1 address and your Optimism address and your layer Arbitrum address and other addresses. And the other technique is meta addresses, right? A meta address is basically an address that has an implied function where you can pass that address as an input, and you can use that to generate many other addresses. So I've talked about meta addresses in the context of stealth addresses, right? There's an EIP for a stealth meta address registry where you can basically register a stealth meta address. And if you have someone else's stealth meta address, that lets you generate an address that they control, but where nobody else can tell that that is an address that they control, right? So this enables things like privacy-preserving donations, for example. Now, the big advantage that meta addresses have is that they are off-chain, right? The problem with ENS is that you cannot have an ENS name until you've already paid fees on-chain. And so if, let's say this person from Argentina is receiving 70 USD for the first time, and they do not want to, spend they don't want to spend like $10 on mainnet for transaction fees, and so their first $70 is going to be on Arbitrum, but then they do not yet have an ENS name, right? So one thing they could do is they could ask their wallet, what is my Arbitrum address? But then it might be better for them to just provide a meta address, which is still off-chain, but which someone could use to generate addresses across multiple networks. Why? Well, because the person who's going to be sending you the 70 USDC to pay for a bike, maybe you don't know what network they're on, and you want to give them as many choices as possible, right? So standardizing some kind of meta address is also valuable, right? And expanding ENS to really think about addresses across different layer 2s and also different kinds of new protocols that are not layer 2s, particularly stealth addresses and privacy-preserving protocols, also valuable. Data custody for privacy, right? Standardizing encryption. So this is one of those areas that has kind of stalled a bit, right? There used to be a feature in MetaMask where you could encrypt to an address and it would just provide a public key. But then that feature got taken offline basically because of fears that there's potential unknown dangers in using the same key for signing in for encryption. But with account abstraction, I think there's really an opportunity in standardizing the idea that there is, instead, you have an ERC 1271 which verifies off-chain signatures, but you can also have an ERC that basically says, how do I encrypt something that the current holder of this address can decrypt? And if you do that, then we can also make that interoperable with the existing PGP ecosystem, and we can actually, really have people have encryption and decryption keys in a really standardized way. And that's useful for direct communication. It's also useful for applications. It's useful for any privacy-preserving application. Standardizing data vault formats, right? Basically, once privacy-preserving applications come into play, users are not just going to be custodians of assets. Users are going to be custodians of data. And if they lose the encryption keys to the data, even if they still theoretically have it in the sense of there being a hash that only they can control, if they lose the data, they can't do anything with it. And so you don't just want to worry about asset custody, you want to worry about data custody. And data custody cannot just be reassigned. You have to actually have an encryption key, and you have to actually, re-encrypt the data under a new encryption key. So standardizing recovery of that is also a challenge, right? So some goals to have, right? I think this is the really, the really important thing to think about, right? What goals do we want to have when we do this kind of transition to having account abstracted wallets and at the same time moving to layer 2s and at the same time moving to having more privacy? One, avoiding dependence on specific enshrined actors, much like EOAs do today, right? We do not want to rely on specific centralized bundlers where you have to call them by IP address. Anything that is done should be done through an open public mempool. We want to ensure easy wallet portability, right? Like EOAs do today, where if you have a seed phrase that you use in MetaMask, you can take that seed phrase out, you can import it into another wallet, and you can use the exact same addresses that you have. So this is something that really should be carried through into the world of account abstracted wallets. Account abstracted wallets should be as standardized as possible. Shared public mempool, like EOAs today, right? So you do not want to have a specific enshrined actor for checking transactions to see that they're okay to be included in a block. You don't want to rely on centralized builders that you talk to with IP address, with a specific IP address. like you don't want users to have to hard code an IP address. Basically, you do not want specific enshrined actors to kind of run like some kind of central server for an entire ecosystem. You want to have a public network that anyone can join, and you also want to have strong on-chain censorship resistance, like EOAs have today, and like EOAs will have even more of once you have inclusion lists, right? So basically, taking the decentralization and openness and censorship resistant properties that we have today with EOAs and making sure that we keep those properties in the world of L2s and in the world of account abstraction and in the world of privacy. This involves like a lot of actual work, and it's important to like really make sure that we're actually doing this, but I think there's a lot of value to be gained in making sure that we actually keep these things, right? So conclusions. The ecosystem is going to upgrade is in the process of upgrading in really important ways over the next few years. Scaling is important. Who here thinks scaling is not important? No hands up. Anyone want to be brave? Come on, anyone, crypto whale, got my 12 million bucks, gonna be safe, never touch it, because touching your coins is betrayal anyway. Okay, good. Improving wallet security. Who here thinks improving wallet security is not important? Okay. Working together is important. Who here thinks working together is not important? Come on, this is like, isn't this like the individualist cyber anarchist crew? Don't we have like at least 2 people somewhere? Okay, good. This is good. I mean, I think it's valuable to really work together and kind of push toward these things as an ecosystem and really make sure that this is something that is done in a way that's kind of inclusive and really takes into account everyone's goals and does not lead to an ecosystem just kind of accidentally dominated by any one single company, right? It's because if that happens, that just completely takes away the it detracts from the value of the ecosystem, and it also takes away the ability of other people who have other goals to participate. And I think as an ecosystem, we've even proven that by working together, we can work faster. VCs totally, poo-pooed that whole concept in 2018. Remember, no, you got to turn Ethereum into a thing. Everyone move to Palo Alto and give people pizza for 14 hours a day and become a company, and that way you'll succeed. And we totally ignored the advice and we're fine, right? So let's still try to actually work together as a decentralized ecosystem in a way that I think we've been surprisingly effective at. And really get the benefits of that, and basically be super vigilant to avoid creating dependencies that we do not need to create, right? The fact that this is this open and global and permissionless ecosystem where people just can come in and start participating is just so valuable, and to me it is the core of the space, and it's something that I would just love to see us maintain and build upon and even improve over time, right? I want to go from high inferior dependence to low inferior dependence over the next 3 years at the same time as doing all of this stuff, right? So let's see if we can actually improve on a lot of these dimensions and create an even more sturdy and robust ecosystem over time as well. Big thanks to all of you for listening. Big thanks to anyone who is actively participating in any of this, and happy to take a few questions.